what is pH value? As you all know earlier, pH value is indicated from the scale of 0 to 14. So, as you can see the pH scale, we understand that whatever substance recorded the pH value is 7 is classified as neutral. And any substances the pH value lower than 7 up to 0 is considered acidic, and greater than 7 up to 14 are alkaline. Now, in context of chemistry, pH value, you must understand that how we get the pH value of the substances. The pH value of the substances is a logarithmic measures the concentration of hydrogen ion in aqueous solution, where we can simplify it with the formula given here. pH is equivalent to the negative log and the concentration of hydrogen ion from the solution. And what is pOH? I'm quite sure that this is first time you're hearing about pOH, right? Okay, pOH is used to measure the concentration of hydroxide ions in aqueous solutions. And the formula for it is pOH is equivalent to negative log and concentration of hydroxide ions. Okay, as we have learned in previous lesson, we know that there are two types of substances we have learned, acid and alkaline. So pH is applicable to acidic substance and pOH is for alkaline substance. Now, the sum of pH value and pOH value is 14. That's where the pH plus with the pOH, we get the scale of pH to 14. So, usually in any substances, we don't mention the pOH, we just mention their pH, that means the concentration of hydrogen ions in the solution. So, to calculate the pH, how we get it is the 14 minus with the pOH. Now let's look at the calculation on pH value. As you can see at this question here, what is the pH of solution if the concentration is 1 times 10 power of negative 3 molar? So what you have to do to calculate the pH is, you take the formula, pH is equivalent to negative log and the concentration of hydrogen ion. Substitute the value of concentration of hydrogen ion given from the question, that is 1 times 10 power of negative 3, you put in here. Then use your calculator, press. Now in your calculator there's a feature button on log. So you type negative log and the entire concentration value, please put it in the bracket and type enter. So for your information, you can do this calculation without a calculator. How? If you find any value which is 1, okay, if the first number is 1, then the pH value of it is equal to the positive value of the superscript. For example, here is negative 3, so pH value will be 3. If you don't trust me, you can press your calculator and see, you'll get the value is 3. Right? What you can see is, without pressing the calculator, you should be able to derive the pH value by looking at the standard form of it. When the value is only applicable if it's 1. If not, if you're not sure, then you better use your calculator to calculate it. Okay. Now let's go to the second question now. Calculate the pOH for sodium hydroxide with a concentration of 0.1 molar of hydroxide ions. So when you want to calculate the pOH, again the formula we're going to use is pOH is equals to negative log and the concentration of hydroxide ions. Substitute the value of concentration of hydroxide ions is given, which is 0.1. You put it in. Now, if it's in decimal, so if you change it to standard form, it's going to be 10 power of negative 1, right? So, okay girls, as you can see here, let's look at the example 1. Calculate the pH value of nitric acid with 0.5 molar of hydrogen ions. So, what you have to do is, 0.5 molar is a concentration, right? Take and fit in inside the formula. Press your calculator. Then you get your value is 0.301. And for your information, we will write the pH value in 1 decimal place. So hence your pH value will be 0.3. Now let's look at example 2. Determine the molarity of hydrochloric acid with the pH value is 2. So now the pH value is given. You are required to calculate the concentration. So you just fit in the value respectively, and then you bring in log of concentration of hydrogen ion is equivalent to -2. You switch it. Okay. When you want to calculate the log concentration of hydrogen ion, the log you bring forward here is going to be turned out to be 10 power of -2. So log is 10 power of, so you bring it over here 10, and then this -2 will be power of. Press your calculator, or you can know that when the standard formula 10 power of -2 is the value is equivalent to 0.01, and because the parameter given here is molarity, make sure the unit you use is mole per dm cube. Okay, calculate pOH value for sodium hydroxide solution with 0.1 molar hydroxide ions. So goes the same thing. You take the molarity, fit it in the formula, because now we're going to calculate pOH, right? So pOH is equivalent to the negative log of the concentration of hydroxide. So you just fit in, press your calculator, then you get your pOH value is 1. You can record it as 1 decimal place. Remember, pOH you record as 1 decimal place of 1.0. Now, example 4. Calculate the pH value of potassium hydroxide that has 0.01 molar hydroxide ions. Now, as you can see, they ask you to calculate the pH value, but what they give you is the molarity. So what you have to do now is, potassium hydroxide is alkaline, right? So when you fit in the concentration, you get the concentration of hydroxide ions. So that's going to be the value of pOH. So we calculate the pOH. Upon getting the pOH, then we use the formula pH plus pOH is equivalent to 14. You manipulate that. So for pH, it's going to be 14 minus the pOH. So your pH value of this solution is going to be 12. And then we move on to the final example here. Determine the molarity of lithium hydroxide with the pH value 12. Okay, goes the same thing goes. Now they have given you the pH value is 12, but you look at the constant solution they give you is alkaline. So that means for me to calculate the molarity, I must know the pOH first. So use your pH, find the pOH. So pOH is equivalent to 14 minus the 12. So we know pOH is 2. So upon getting your value of pOH, you feed into the formula, find the concentration of hydroxide ions. And remember girls, whenever they ask you to determine the molarity, then your unit must be mole per dm cube. Okay, so now we're going to investigate the relationship between pH value and the concentration of hydrogen ion through experiment. Okay, what you require to carry out this experiment is, the apparatus required is beaker and pH meter. The materials are, we're going to use different concentration of hydrochloric acid and sodium hydroxide solution. Okay, it's a very simple experiment actually. You will measure and pour a definite volume of the hydrochloric acid of different concentration, okay, and you will pour it into a respective beaker. Then use your pH meter to measure the pH value. When you dip the pH meter, you'll get the respective pH value ready. Okay, now upon getting the data on different concentration of acid and alkali, we're going to learn the relationship between the pH value and the hydrogen ion. Okay, what the conclusion we can draw here is, as you all know that earlier itself we have already know, any substance the pH value is lower than 7 is considered acidic, right? But how we differ the strength of the acid? If it's, let's say I have two type of acid X and acid Y. One is pH value is 1, another one is pH value is 5. So you must know the relationship between the pH value to the concentration of hydrogen ion. So as you can see the arrow here, you must understand that as the concentration of hydrogen ion increases, the pH value decreases. Okay, now I want you to relate to the strength of acid which you have learned earlier. Strong acid and weak acid, remember? Okay, so generally the strong acid will have a lower pH value compared to the weak acid. Why? Because strong acid have a higher concentration of hydrogen ion compared to weak acid. So the relationship between the hydrogen ion concentration of hydrogen ion to the pH value is, as the concentration of hydrogen ion increases, pH value decreases. Okay, this is the first relationship. Now, What is the relationship between pH value and hydroxide ions? Okay, any substance, the pH value which is greater than 7 is considered as alkaline. So, how we classify them is alkaline. I want you to relate to the previous lesson on strong alkali and weak alkali. If I have two type of alkali X and Y, one is pH is 8, another one is pH is 13, which one is strong alkali? Yes, correct. The pH 13 is a strong alkali, whereas the pH 8 is a weak alkali. Now, based on that knowledge, I want to relate to the relationship between pH value to the concentration of hydroxide ions. For hydroxide ion, as the concentration of hydroxide ion increases, pH value increases. Okay, as you can see here are different type of substances which are dealing almost every day in our life. Okay, so pH value is something which is cannot be apart from our daily life. It's immersed into your life. So now we're going to learn on what you have learned in theory in a virtual lab. Okay, so let me take you to the virtual lab. Let's look. First thing, let's drag and put one of the bottles here. Now I'm choosing sulfuric acid. So as you know, in sulfuric acid consists of hydrogen ion and sulfate ions. So the first thing, we're going to measure the pH. Remove the cap of the bottle. We're going to dip the pH rod into the solution and pH meter shows the reading. Now it's 1.2. Okay, that's based on measuring. So now let's go based on calculation. How do we go about the calculations? Let's click. Now, as you're aware that 1 mole of sulfuric acid consists of 2 mole of hydrogen ions and 1 mole of sulfate ions, right? Okay, so the initial concentration of the solution used was 0.03. Now, when the one number of mole of sulfuric acid produces 2 mole of hydrogen ions. So in that sense, 1 molar 1 molar sulfuric acid produces 2 molar hydrogen ions. So the current concentration of the solution we used was only 0.03. That means the concentration of hydrogen ion in that particular solution was 0.06 molar. So what we're going to do is we're going to substitute the concentration 0.06 molar into the formula for the calculation of pH. So we're going to pick the value for concentration of hydrozonium ions. So as I explained to you just now, the concentration of hydrozonium ion in 0.03 molar of sulfuric acid is 0.06. So when you fit in the value of hydrozonium ions, let's drag and drop 0.06 molar. Yeah, you're right. So when you press your calculator to this formula, you get 1.2. Now let's go to activity 1. Calculate the pH of the following substances. Okay, so now I want you to take out your exercise book and copy down this question and try to do it. So what you have to be very careful about, look at the type of the solution given. If it's acid, then we're going to calculate the concentration of hydrogen ion. If you find is alkaline, then we're going to calculate the concentration of hydroxide ions. Okay, upon completion, you can check your answers.
Good luck.